In this problem, we're told that there are approximately 270 million passenger vehicles registered in the United States, and we're going to assume that the battery in the average vehicle stores about 520 watt-hours of energy. So, and what we're trying to find in this problem is basically the total energy stored in US passenger vehicles. So how are we going to do this? The first thing I always like to do is write down the given. So what information are we told? We're told that there are approximately 270 million passenger vehicles. So let's write total number of vehicles is equal to 270 million. So 270 million. And so instead of writing it as 270 million, I'm just going to write it as 270 times 10 to the 6. Right? So keep in mind, this is 270 million vehicles. Let me write that. Vehicles. And so instead of writing million vehicles, I'm just going to write it in like this, 270 times 10 to the 6 vehicles. Million just means times 10 to the 6. So 270 times 10 to the 6 vehicles. So there we go. And then we're also told how much the average vehicle stores in terms of energy in its battery. So I'm just going to write EA. This is just E average. So this is per vehicle. And we know it's going to be 520 watt-hours. So yeah, so this is what we're given. And so what we're trying to find is the total, right? The total amount of energy stored in all of the vehicles. And so the way we're going to do this is simply by just multiplying the two values, but you're going to have to do a bit of unit conversions. So if we know the total number of vehicles and we know the average per one, if we just multiply them, it's going to give us the total amount. So basically, you're just going to take 270 times 10 to the 6, and then you're going to want to multiply it by 520. So let's go ahead and do that. So take out your calculator and plug this in. So 270 times 10 to the 6, and then multiply by 520. And so you're going to get 1.404 times 10 to the 11. And so what are the units of this? So keep in mind, this was watt-hours. And so this is just an arbitrary number. So you don't actually have to include this unit. So this is just watt-hours. But keep in mind, they're asking for the answer in gigawatt-hours. So we have to convert. And so you basically do that by doing this right here. So I'll write it out. So 1.404 times 10 to the 11 watt-hours. And so we know that 1 gigawatt-hour is equal to 1 times 10 to the 9 watt-hours. That's what giga means, times 10 to the 9. So essentially, all you got to do is divide by 10 to the 9. So you're going to want to take your answer and divide it by 10 to the 9. And so you're going to find that it equals 140.4. And then now our units are, these will cancel, and you're going to get gigawatt-hours. So we'll write it over here, 140.4 gigawatt-hours. But yeah, so essentially all you got to do is just take the total number. If we know the average, we can just multiply it. That gives us the total. So yeah, and then make sure you do your conversions correctly. But this is what you should end up with, or something similar. Your numbers might be a bit different. But yeah, so this is how you do this problem, and hopefully you found this useful.